There was only one person doing the hacking yesterday, and I think so they can go to 415 if they want to, because they'll be close to 410. And track 3 will be in 319 instead of 312. So James, you are here. I don't know if the others are here from yesterday, but we can go to 319 and do a little bit. But also what I wanted to mention to people is that we also have provided some additional notebooks in the same box. So these are not necessarily solutions, but these are some approaches. So you can see some of the things that you could do with CNNs and so on there. Sorry? We have put them in the same box folder that is linked from where you picked up the data originally. So there is a third file there, an extra file there. Yeah. So these are 10 megabytes, all the notebooks together. So you should take a look at those. And the Zoom link will be the same as yesterday for those who are joining online. And one thing that you should do is that you should prepare your presentations, something short that you can present about 1 hour from now. And there is a slides link there where you can drop those in. Give your team a name. And then there are prizes, right? Meaning that's the important part. But one of the things that we're hoping is that there's a template on the Google Docs. So there you can say what you have worked on, but also whether you'd be interested in presenting that at one of the Stride meetings later, either in April or in May. So a quick show of hands, how many of you are working on track 1? Okay, several. Track 2, several as well. 3, okay, 2, 4, okay, there's 1 and 1, good. So 5, the remaining, okay. Yeah, good. I think there's a fair distribution. So it's 2:15 now, 2:10. So we should meet here at 3:10. Yeah. Yeah, because so one of the things that they should do is that prepare. We said 3:30 we finish, right? So before that, they need to do their short presentations. And then, so if people are willing to wait, but I think there may be some people who are ready to go. So they can continue later on. But so I think that's what we should do. So by 3:10, get back here. Have your presentations already in that slides beforehand. So, and um, so I'll put that on the Slack also. You don't have to type that in. On each of the hack channels, I'll put that link to the Google Doc where you can drop your presentations. So there are multiple identical slides I have made. Start from track 1, track 2, change the name that you're using. And if multiple people are doing differently the same track, you can make a separate slide or two as well. Any questions? Any issues that came up so far? So for instance, some things that were noted is that when you read in the alerts, there are some columns that have nans, and the default file was converting that to 0. That was just shrugging under the carpet thing, right? So that you can deal with the way you want to deal with. Or there was some 311, 312 issue. So 311 is generally better with Python. But otherwise, anything else that anyone found? Oh, yeah, that's different. If you have the data locally, then it shouldn't matter. But yeah, for the new files, for the solutions, maybe yes, yeah. All right, you know your rooms then. And if you are quiet, you can also be elsewhere. But your TAs will be with you. So the TAs are here. Matthew, Ilaria is not here today, right? Oh, she's outside. Okay, right. Okay, right. But Ryan, you and you, okay, yeah. And then Jacob is here, and Vin is there. So, and I'm here. So, all right, let's do it. All right. So I don't know what order people have put their slides in. So why don't I just advance to the first one and people can claim their slide, come and speak to it. And one or more people, all should be fair game. All right.
Hi, everyone. I apologize for putting this in the front, but I think this is track 0. So yeah, basically, I think that most of the tracks are based on existing different images based on region. Yeah. So as I said on Wednesday, I think it might be worth unifying the pixel grid as well as the PSF. So I did that. So this is a set of different images based on 10 images that Jacob gave me. So these were taken in autumn 2028. Anyway, so basically I stack all of them to make the reference images and subtract the individual image, subtract the reference image from the individual images. This is a very small chunk. This is about 40 arcsecond by 40 arcsecond, but I think we can already see a few eminent transients. If you see dipole features, that is because I'm not using the right input PSF model. So I think that can be fixed. So for example, here and here, you see some dipole features. Those can be removed if the right PSF models are used. So anyway, I look forward to exploring more possibilities with this. Thank you. Okay, I'm not sure if I need the team name because it's just me. And as for the Stride, I haven't been to Stride meetings, so maybe I'll learn more in the future.
The output from Fast IMCOM, what are we looking at?
I'm sorry?
What are we looking at?
We are looking at a set of different images based on the 10 images Jacob gave me and processed by Fast IMCOM.
Oh, okay, got it. Yeah.
Then we get a diff image.
Yeah.
It's hard to compare because the pixel grid is different. Yeah, it's a bit different to compare because the pixel grid is different. But yeah, we can just look up the same region.
Yeah.
Okay. This might be taking a bit long than expected, but I would like to explain that Fast IMCOM is like the combination of PSF matching and subtraction. So basically, if we use Fast IMCOM, then the individual images and the stacked images have the same PSF, so they are directly comparable. So I think that's the difference from the region product. Anyway. Yes, so we don't have to do special PSF matching when we subtract. Okay, thank you.
Next. All right. Matthew, Jacob, Kate, Gemma, who are all going to come here. No.
There is now an official AMPL Roman repository where you can ingest the test alerts. And actually run Lightcurve. I don't know. There would have been, people have already left. Would have made some people happy.
Good, good, good. Any questions? How does it work? What does it do for people to ask?
So what it does is so this is a piece that allows you to take to parse the alerts and add them to an ample local database. So not quite yet cross-matching with other, but in principle, you could do things like matching to catalog and run a classifier or something.
And do you have any feedback for us on what we should improve in the schema and or to make the
mean-
life easier for the broker?
I mean, the schema is so similar to LST, right? So
So it's good.
I mean, that is good. I think it will be, I mean, that's something that we discussed, whether it will be possible to, from the beginning, cross-match to the LSST databases to have that information there as a unifier.
Okay. Awesome.
Great, yeah, thank you. Yeah, let's clap again. All right, next. Stars and galaxies. Who's that?
Yeah, Priscilla can.
Yeah, I think Priscilla was the only non-TA in that group.
Yes. Well, we basically what we did then we inspect the features that we had and we check the test random forest that was given. We tried to do some feature importance, but we were not very successful, mainly because we were trying for a long time. We tried to understand the features. Yeah, we have a confusion matrix that is doing very well already for like galaxies. But then we like also discussed some issues with this not having like why would we want to tag transients at this level when transients should appear in the difference? So do we care about tagging transients or just galaxy star? Yeah, exactly. But we have transient tags also. And the other problem is like a lot of galaxies look like stars. So yeah. So we have a lot of open questions and not many results.
Transients all be stars as well because they should be point sources.
For some reason, they are galaxies.
I think what happened is that most transients are on top of galaxies in the Open Universe 2024. So
I mean, then why do you need a different category for
you
transient?
don't necessarily need a different category, but
Yeah,
that's
this
how
is
the
what-
data set was prepared. And so
Oh,
what you have is you do it. Meaning one of the questions was, can you also separate the transients? And that is what was included. It's not necessarily what star galaxy separation needs to be doing, but so when we have both transients that are more orphan transients and on top of galaxies, that question will be slightly different. All right, thank you. Next, we have track 5, Sander, Mitchell, Lee. So who is presenting?
All right, so I guess for this track, you're trying to classify whether an auto white curve was a transient star, galaxy, or an artifact. So I did the very trendy thing and tried to tokenize all the white curves and then just built a classifier on top of that, and it did marginally okay. It's pretty bad at transients, which is probably the most important thing, but yeah. So.
Though, meaning many of them are really faint. So if you do a separation between at what magnitudes they're bad and at what magnitudes they're good, you may find that if they're bad only for the really faint ones, then I think most classifiers will indeed fail there. But if they're doing well at the brighter ones, relatively bright ones, that's great.
Yeah, I think when I looked at some of the white curves too, it was like only, there's only a couple of data points too for the transient.
Yeah,
So
exactly.
I don't even know if
So-
I would consider it.
I don't know how many people looked at the data in detail as to what was provided, but we had the data from what are called 15 different jobs. So 5 of them had 0 history. They were right at the start of Roman. 5 of them had 1-year history and 5 of them had 2-year history. And so there was a very different kinds of combination of those data there. Would you want to say anything about the method itself? Or?
We just, I mean, I just built a tokenizer, and we just, subtracted the MJD to just how many days from the first observation, and then it just,
Right.
It was a
that may be
very
another
naive
thing to
method.
do. So which are the ones that failed? If it were ones which are the fewest points, because then it did not have enough context there. Right?
Right. Yeah. I mean, there was definitely a lot of stuff I think you could do with augmenting the data set as well, assuming like this was real data and we couldn't just simulate more. In terms of just like, interpolating white curves
Yeah.
to
So
make
you
better
should,
data.
I would say you should definitely develop this into a method, because the data we had is 15 JIDs and we have got how many? 20,000, Jacob? Something like that, right? JIDs, jobs, yeah. So it would be great, meaning if it just works out of the box like that with whatever you have built, we should definitely try that.
Yeah.
Great. Thank you.
Xander and Michelle. So also credit goes to them. So yeah, similarly, like I also like use machine learning classifier and the random forest was used. There was like it about transients, like there were 93 in the sample. So that is another problem, like low number of data set. And like galaxies and those were like around 1,000 or something more than that. And so yeah, for my confusion metrics also like 52%, like there are a lot of galaxies and transits were getting confused, and that was the main thing. And other thing is like other way of like finding whether galaxy or transient is there or not is like also include the timestamp, because later like transient won't be there at that place and galaxy would stay. So it can be like based on like our scientific knowledge, it can be improved. Yeah, that's all.
Yeah, I would say even for this method, just like what they did, getting a bigger data set will definitely bring out some of those things. And again, distribution of transients. So you do get a fraction of them, right? So.
And also it is like 90-minute hack and
Oh yeah.
time
So again,
to
that's the whole point. That's why the stride thing, right? Meaning you can continue working. There are S3 links there, which you can download the data further. And-
get like better results
Absolutely.
to understand the data.
Galaxy, sorry, it seems like the star galaxy is really good on this one, right? On 72% and 85%.
Yeah, so each thing like balanced for I gave like more weightage for depending like when the confusion matrix was like giving low numbers, so I increased the weightage, so like increase the transient weightage because it was getting the low numbers and was not getting understood properly. And for stars also increased by twice or thrice.
Yeah. So those are the kinds of things that may be useful to also document that perhaps in this.
Yeah. So yeah, yes, switching using the parameters, you can get the better results.
Thank you. All right, 617.
Hi everyone, it's 617. It's me, Sasha, Rujula, and Ines as well. So we were also trying to use like tree-based classifier with selected XGBoost. What we did differently is that we try to include different modalities or like representation of modalities. So for the light curve input, I did the TS-Fresh parameter extraction because it gives you a lot of statistical parameters to work with. And also we generated some DMDT images, which we inputted separately through the vision transformer. And we report our results based on 10-fold cross-validation. So we can like roughly estimate the uncertainties from the standard deviations to see like how uncertain our scores were and how they differed for different separation between train and test. So status, we're definitely not done. I wanted to also try to add some additional modality of image cutouts, which are also available. So I will try to add them through VAT as well, or maybe different encoder, and see if it helps. And yeah, can we have the next slide? Okay. Okay. So these are our results, like in general with our initial setup. So we got 74% of one score with tenfold cross-validation with the following uncertainties, which weren't very bad. Well, they were bad for the transient class because there is not a lot of the transients available, but in general, the macro average at one score was pretty good for this situation. And also compared to other teams, it's like on the similar range. We also generated some ROC curves to see how it generalizes in general, how it's like selects the classes. And also what I've tried, like I'm right now experimenting with the idea of changing the thresholds for the classification. When, for example, we have transients, which clearly for every team perform the worst, we can try to lower the classification threshold. So classifier kind of favors it. So I did that. I ran like a little bit of like a parameter grid search. And then I changed the random seed not to introduce a little bit of leakage. And with that, like optimal threshold search, our F1 score increased a little bit to 76. And the transient score increased to around 52, which is pretty good. And I think it's an interesting topic to explore in general, how we can search for like good classification thresholds we can fix and use in real-time classification for like less favorable classes, I would say, of which we have less in quantities. Yeah, so those are our results. And we would be happy to present at STRIDE meeting later when we add additional modality and maybe introduce some other changes.
Chance. So did you get to the cutouts at all, or you just not, because we talked about it a bit earlier, you could not incorporate it at all so far?
Oh, no, I just found out like 20 minutes ago that we can use them. I already started writing up the code, so it will be available probably today, but yeah.
Any other questions?
Can you explain what is the F1 score compared to like just the recovery rates that you have? How is the F1 thing computed?
So I think it's computed as combination of true positives and false positives. I don't remember the formula itself. Is it like the product and sum or something like that?
That especially when there are multiple classes and there is imbalance. Because if one is looking at only accuracy, what can happen is that, especially if there is an imbalanced class, everything can be put in that class and you get very high accuracy. But then all the other classes being subsumed in that class. So F1 score makes sure that it does not give that skewed interpretation. No, it takes
No, it's everything.
Yeah.
Like usually what I report, like in my works, I have confusion matrices separately for completeness and purity, which show a little bit different things. But I feel like for astronomy, it's important to see like both separately, because if you're interested in not missing, for example, a kilonova, completeness would be a bit more important than purity as for me, because it like ensures that we don't miss a class that we want to find, which is like anomaly class we are very interested in. Yeah, completeness, no, but F1, it uses both purity and completeness. And we definitely shouldn't use accuracy. Yeah, it's very biased towards like very well-sampled class. Yeah.
Two classes and
Oh,
they're
yeah,
fully
yeah.
balanced. So then that's the same. All right, thank you.
Thank you.
Okay, the boguses.
Okay, team boguses. We're on track 3, playing around with just real bogus classification. So James and I tried a couple different things. This slide is on mostly decision trees. This is a confusion matrix for an XGBoost model. Yeah, 0.9 F1 score. Did some feature importance to learn what features were most important. Unsurprisingly, it's like the PSF morphological kind of quality things. We also tried a CNN on the side, which wasn't doing too well. I think because it takes longer to train, it takes a little more iterations to get things going. But this is a preliminary histogram of the scores, and you can see that it's starting to separate two classes, but still some more work to go there.
Thanks, Nabil. I also tried a random forest using basically off-the-shelf sklearn parameters with a handful of the features listed there from the alert stream. Oh, okay. This must have been uploaded. I made a couple changes after it was uploaded, but basically I was saying at the end what we said earlier in the before this the hack session started, that there's a lot of nans in these features that we are using to determine. So we need to properly address those. I overrode all of them with zeros. No, it was just the that line. And yeah, so I replaced all those features with zeros and let the classifier try to figure out if that was important or not. It seems based on the scores everyone else is getting that I should have been removing those NaN values, but we're still getting reasonable 85% precision and recall on the bogus objects and 74-ish% on the real objects. And yeah, next steps, just look into various enhancements, modifying parameters, getting a better idea of what the objects are that fail the test, so we can actually modify them intelligently instead of just clicking around.
James and Nabil. Okay. Yeah, so what you mentioned right at the end is quite critical. So when there are misclassifications, looking at those is the most important thing, because that really tells you where things are going wrong.
Quick one question. So you tried two complete different methods, right?
Yep.
And which I don't remember the numbers on the previous slide. Which one worked better and why?
Yes, there was. So here there was the XGBoost, so decision tree based, and then the CNN. CNN was a little bit trickier to train, so that's not really like quite done. And then James did a different kind of decision tree that was a random forest. I think, can you flip to the next slide? Yeah, I think the XGBoost had slightly higher scores. But I think I added some additional columns, did some searching of hyperparameters. So that could have just been the difference between those two. But yeah. Yeah, not necessarily.
But also XGBoost tends to be better because it selects certain features and subsets of trees from what random forest does. Random forest takes normally all columns, all rows. It does do selection, but XGBoost does a more methodical selection. All right, thank you. And we definitely want to see that CNN happening.
All right.
Oh, something jumped in. Oh, okay.
All right, we're the astronomists. I never thought we'd be following Team 67, though. That's 6-7. I thought I'd get away from my daughter for a week, but man, I'm feeling older and older. It's now in the astronomy conferences, so cool. All right. So, I mean, I don't do a lot of machine learning, but I partnered up with two great people, Constantine and Claude. And I'm trying, if you haven't heard me throughout the week, I'm trying to start understanding how to classify high redshift Roman data and some very sparse JWST data we have, hence the Space Telescope supernovae. And so I sat down with Constantine, and he had this idea to use a pre-trained model for called Astromer 2, which was trained on the Macho data set, and use that to see how well we do against the Roman simulations, which I don't know the details about how the hourglass simulations were made for the high latitude time domain survey, but we sort of did just apply this blindly. We used Claude to read all the documentation for us and actually implement the test. I'm not entirely sure the details about the implementation, but here is our resulting confusion matrix. And Constantine says we should be pretty proud of this. It's actually pretty good, because even though there's a lot of very small numbers here, the key is that for the high signal to noise objects, the ones with a lot of samples, we actually do have a pretty good correlation there. For the objects that have very little data, just a couple objects, we do pretty poorly on. But overall, just within an hour, being able to take a pre-trained classifier and put it on Roman, we're pretty happy with those results. So then what we want to do is sort of retrain, if we were to go down this route, the current model on the Roman data, and then ultimately on our actual data from JWST, and then eventually Roman. So that's where we're at. And I'd be happy to present, but I'm more happy to get feedback and other inputs, and how to make this a lot better than it is now. Thank you.
Data that was used for this.
Yeah, the input was this Astromer 2 model. Oh, the input data itself it's called the Hourglass simulation.
Oh, it was that simulation.
From the Supernova 1A
Okay.
pit,
Right.
which is publicly available. Yeah.
How do you feel about your pulsational instability, pair instability supernovae, all three of them landing in the core collapse bucket?
Yeah, well, that's what we were. That's a great point. I did notice that, and that's exactly what we're trying to do, and we failed miserably. So, yeah, great point. Step one. This is that you can hopefully one day come back to this, and hopefully we'll laugh when we find our first pair instability supernova.
Tease Kostia about this. He was talking about the columnar readouts, right? And here the CM is columnar right now, right?
Oh, that's
One
a good
column with all
point.
the classification.
What does that mean if it's a column like
No,
that?
that
Just-
means that it's wrong. Right?
Well, I know that part. I know that part. But it means everything looks like a core collapse supernova, I guess,
No, but
right?
Your
Okay,
point
so-
was right that the first three elements are diagonal, and towards the end we have a little bit of diagonal as well. So
Yeah, well,
some
actually,
classes.
I just want to make this point for people not paying attention closely. For some reason, the confusion matrix came out that the most popular supernovae are at the very top or at the very bottom, and everything in between is stuff that we rarely talk about. So anyway.
Yeah.
For the light curves from the simulation, do you know how similar or different they are from the light curves from the alerts package?
That's a great question. I did not look. That's a very good question. I should look at that alerts package, and then we could run that through too. Yeah. Do you know the answer to that? Have you compared the alerts package to the Hourglass?
There are some from right at the start of Roman, again, everything simulated, of course, some from 1 year later and some from 2 years later, right? And so it's a mix of that kind. And as far as the classification, no, we have not looked at that at all. So that's one thing that the truth information should have that somewhere in the Open Universe 2024, we can figure out which ones were those. Yeah.
Didn't use Open Universe. We couldn't figure out how to get, it didn't seem like there was a nice compact table that just had all the truth catalog for the transients. So I don't know if somebody, I don't know who's been looking at Open Universe the most, but if that exists, that would be interesting too. It's there, we can, okay.
Right, thank you. All right, track 2. Let's quickly see how many more we have. Okay, last one, I think. Yeah.
Okay, so we will work on track 2 transient detections. We use a autoencoder to try to inject about 100 transient are injected into the different Roman images, and we build the autoencoder to predict the location of transient. As this is some initial result. The white dots are the injected transient, and the black circles are the predictions. The autoencoder take the image and make a mask to mask the locations of transient. As you can see, we got at the moment and about almost every circle there is a transient inside. So we achieve a high precision, but there are missed a lot. So the model currently have a low completeness. Yeah.
Thank you. Questions? So do you have a number on what is the recall and completeness? You said it's not complete enough, but
Numbers, have not get a chance to calculate.
Okay.
About half.
Okay,
From
no
the
worries.
image.
What does it mean that the size of the circle is bigger?
The size, the model currently assume a Gaussian distribution. With the
So that's kind of like a, I don't know, an uncertainty or a.
Oh yeah, yes.
Yeah.
Okay. All right, thank you.
Okay, it's time for the prizes. So we didn't have a very good plan for this. So we're going to do this by popular vote. We live in a democracy. So we have a total of 6 prizes. So you can vote up to 6 times, but not more than 6 times, okay? So we're just going to go through the teams and we're going to write down votes. And the top 6 teams get, the little tote bags, okay? Yes, if you can go through the team names, then we will do votes, okay? So everybody's allowed to vote at multiple times as well, but no more than 6. Okay. Kylie's Fast Imcom. Okay. Okay. Can you see here? Yeah, can you edit? Yeah, let's just edit on that. Okay. I'll just count the hands. You can write. Okay. Escape. Okay, very quickly. Okay. Fast Imcom. You want to decide? Okay, Ryan wants to be judge. Okay, Ryan.
I took some notes here. Okay, so I think the one that I liked best from track 5 was Team 6-7. So I know there's 3 of you, but I think Rajula is the only one who's not local, right? So she can take the prize. All right, track 1. That's yeah, you can take that one. This is you can take anyone. All right. Track 1. Okay, so this was, I think, just hearing the news from Jacob about Empole, I think he deserves the prize for that one. Also, he traveled probably, I think, the furthest. Yeah. Yes. Yeah, we have one for each track, and you're yeah. Okay, and then let's see, we have okay, there are two rogue tracks, track 0, which is Kylie, and the Astronomists. So this was, oh yeah, track 5. Oh, okay. I think you were beat out by Team 6-7 though. So Kylie gets the rogue one here. Here you go. You can take this. Yay. Here you go. Okay, and then let's see, track 4, which was my track, and there's only one other person in it. That'd be Priscilla. I'm not buying this. I didn't buy this for myself. So you can choose any one of these here. Yeah, just take one. Anyone. Yes, feel free to give it away if you really feel like it. Yeah. Okay, track 3. So it's either Nabil or James, right? And Jacob. So I'm gonna just say who traveled the furthest to get here. New York, Chicago. Right, there you go, James. So feel free to take your prize. Okay, and then we have one more, right? So track 2, which is either Rodrigo or Xiaolong. And so this is a tough call, but I think as presenter of this, I think it goes to Xiaolong. Here we go. Congratulations. All right. Good. Yeah. All of you should do the last right soon. I have a last slide here to share with everyone. Let's see. Where am I? Drive. Okay. Final side here. Yes. Okay, so yes, I want to thank everyone for being such a radiant and infrared radiant community. This is our team, our conference photo right here. And yeah, we'll see you next time. So thanks so much, everyone.